welcome back under the desk, and it's a new one this time, so let me formally introduce it. We have Plug Socket, Weird Socket, Inspirational Messages, This Idiot, Cuentos Españoles, and the Promise of Yu-Gi-Oh cards. Now, amongst other things, this time I added shaders to my game. You have to look at this pathetic sprite animation no longer. Feast your eyes on this. Look at this. I could sit here and just watch it for hours. But there are shaders to explain, so I won't. So first, let me explain what shaders are. So the CPU, as the main brain of the computer, has a lot of things to do. Its instructions are very broad, from bit shifting to jumping about in the program to complex vector additions. All in all, they have 1,503 instructions. What do we need all of those? What does this one do? NOP, an assembly language instruction that does nothing. When would I ever need to use NOP? In contrast, the GPU focuses only on graphics, and so its instruction set is much smaller, much more focused on graphical maths. Although apparently they still have NOP. Am I the crazy one here? Not only are the instructions simpler and more focused to maths, more of them are run at once because there are more processing cores. And I'm talking hundreds to tens of thousands more than regular CPUs. Like how you can program in C++ or Go and compile it to make the computer do the bloop bloops, the GPU has its own bleep bloop languages, and the one I learned was GLSL from the website The Book of Shaders. It's a fantastic, completely free online book for learning how to work with shaders, and within a few hours I was able to play about with them. And then I was inspired by this YouTube video by a channel called Jasper on the water in Mario Galaxy, and so I tried making a lovely beach. Link to both of these resources are in the description. Now, what do my shaders actually do? Well, let's start off with just the water. This tile here, copied a bunch of times across the screen. However, as well as the water tile, we also have this noise here. Each pixel is only told where it is on the screen and where it is on the texture. It has no memory of what it used to look like or what its neighbours look like. Therefore, we need to use this noise in order to create the ripple effect. So, it looks where it is on the noise texture, and if it's black, it moves where it's sampling the water texture down and to the right. If it's white, it moves it up and to the left. And of course you have the various in-betweens as well. Finally, you can scroll the water and noise in different directions to make the water seem as if it's flowing, but without you being able to quite tell exactly where it's flowing. If you want more details on exactly how density of the noise, strength and pull of it, size of textures and so on, as well as lots of fun other things you can do with scrolling textures, I would again recommend Jasper's video. The next thing to look at are the waves. This one again uses two images, a beach and then this weird soup here. So for this one you need to think of black as 0 and white as 1. As a sine wave goes over time, if you take its absolute value, the positive value, it only goes between 0 and 1. So each pixel is not only told the two textures, it's also told what time it is, and it feeds that time into the sine wave and looks at the value. If the value of the colour of this wave soup is less than or equal to the value of the sine wave at that point in time, you draw the texture. Well, this is a nice start, but the water doesn't quite look like it would pass the EU's Bathing Water Regulation 2006/7/EC. So, we have a little ways to go still. To start with, we can redraw the texture as blue and slightly transparent. Then, instead of just drawing the sand underneath, we can apply the same displacement noise as with the main water texture. And speaking of the main water texture, let's slowly fade a bit of that in as well. Finally, as a finishing touch, if the value of the colour on the wave texture is just close enough to the true value of this absolute sine wave, we just draw white, which gives it this nice foam effect for free. Now, this still isn't perfect. The wave rebounds off the bottom extremely quickly and it stays extended, hung out for way too long. But compared to the wave detail I had before, I think this is a solid improvement. The final step is this layer here, which creates a nice fade between the two shaders. This is as simple as taking the outputs of various functions in those shaders, so we covered everything there already. And there you have it, graphics that would put the rest of my game to shame. But there's just one problem. This isn't in my game. My game can't handle shaders, so it's time to rework the tile system. Again! But shaders aren't my only goal this time. So, as you can see, instead of just changing the properties on a tile basis, you can actually, if you look in the corner, assign little collision boxes that can have different collision in it now. So I'm taking advantage of that, and now, instead of full-on collision, I can collide at certain points. So that's what I'm working on, but what I have, if I look at that over here. Okay, so this is happening, I think, because I'm halfway through remaking the sprites, but it still thinks that these are water tiles. Well, let's ignore that. Right, ignore that too. So currently, look, if you there's a wall here, right? There shouldn't be, because I'm not part. Ignore that. Pretend I went round the long way. Look, clearly I should be allowed through. I should be allowed through there. Clearly, can't walk up here. Right? I'm getting caught on a corner that doesn't exist. At the time of recording this, I'd already changed the level data to have the new collision types, but the code was reading it expecting the old collision per tile data, which is why it's embarrassing me like this. What I was trying to say is that there are invisible walls on the map due to the collision, where you would expect the collision to actually be elsewhere. Also, I'm now storing collision as 1 byte of 8 true or false flags, and then you can logical AND them together to see if there was any collision, which is just one simple instruction, instead of before where I had 3 separate bytes that you could selectively check against, and that made the code a lot more complicated. Little did I know though, this change would create a major problem. So I changed the art back to be less seizure inducing, set to work, merged the entity code I was talking about last devlog, which sent me down an entire rabbit hole of new issues, and finally was able to get some more tests done. There is a 10% chance that this works, 50% chance that it crashes, and 50% chance it's a white screen. Yeah. Both! Magical! Well, it's not a crash. Enemies still work. Yeah, they can still run. Understood. Finally, I was able to properly load in and place the collision, which you can see from these tasteful dots. However, it was at 1 AM that I learnt that finding the collision and colliding with the collision were two completely separate problems. I was still phasing through everything, and so I did what any sane, rational adult would do in my place. I went full monkey and then went to bed. The next day, I realised my problem. Do you remember how I said that you could AND things together and that would check for collision? Well, turns out that AND and OR are not the same thing. You see, when I was creating these collision flags, when I was telling the player what to collide with, I was telling it to collide with A and B. Now, these are two completely different flags, so they end up being 0. And this one symbol causing everything to break is way more common in programming than I'd like to say. And it took me hours to fix it, and I was losing my mind. The point is, the next day collision was fixed. There were a few hiccups in the shader department. The waves were going the wrong way, and neither the fade nor the water shaders seemed to be working. Then, the water shaders started working a bit too well. And Also, apparently I'm drawing the water based on where it is on the screen rather than the map, which was just, more time wasted. And finally, this is where we end up now. It's not perfect. In fact, there still seem to be a few bugs here and there, but the entire map and tile set is only here for testing purposes, so spending more days reworking this entire thing so that it would look nice is a waste of time, sadly. This is as good as we're getting for now. The main point is that the shaders now work, and I know what small things I need to add later on down the line to make them easier to work with in the future. Yeah, speaking of bugs, as you can see, we still have that issue accurately reading tile rotations, and the new collision system seems to have broken the pathfinding entirely, but these are, say it with me now, problems for another day. There are a few other things I have in the oven cooking right now, but this is starting to drag on a bit, and none of them are viewable just yet. So I think I'm going to end this devlog here. I hope you follow along next time as well. Bye!